Yes, hello, my name is Jan Erik Hoel and I'm responsible for Novapoint Tunnel, and I will now show you briefly how Novapoint Tunnel works in Novapoint 19. Part of this is already released and some of this will be released in late October this year. So here you see Novapoint 19 desktop, and what you first do is that you go to the modeling tool, and here you find Novapoint Tunnel as a modeling tool. You can either choose to import an existing tunnel project made in Novapoint 18, the previous version, or you can make a new tunnel model. If you make a new tunnel model, you have to connect to a road. It's very important that the tunnel is connected to the road, and the road is the master for the tunnel. So this is a road. I connect to a road and make a new tunnel project like this. I cheated a little bit, so I have imported an existing tunnel. So I will open this tunnel now. This is the design window that I open. Just wait until it's opened, and here it is. So in this window, I do all the design work with the tunnel. We say that the tunnel exists of different structure elements, and these elements are inner profile. This is the inner profile. It's perimeter, the yellow one here. It's left pavement and right pavement, that's the curbstones here. It's free space, that's the driving space. It's the sign base. You can have either contractual base or the sign base. The sign base you can make a little bit as you want yourself as a contractor. Bolts, mounting bolts, as we can see here. We can define niches like this, and we can define crossing tunnels like this. Also, we can include scanner data and triangulate the scanner data so that we see both the scanner points and the scanner surface. I will now go through all these functions or structure elements rather quick. First one looks like this. The inner profile is the master of the tunnel. So what you do here, you decide what kind of tunnel you want to have. You can choose between different types of tunnels like this. They are all parametric. Then you connect to the road by using this connecting mechanisms here. And in Norway you have a rotated tunnel, so you can decide what lines in the road model that decides the rotation of the tunnel. And you have a lot of parameters. All this together makes up the tunnel geometry, inner geometry. And then you choose to specify the perimeter, either just as an offset of the inner profile, or you can define it as the inner profile with a lot of parameters. Straight walls, flat roof, curve transition curves, etc. The pavements you define like this. Some parameters. You can either use the standardized curbstones, or you can define your own geometry as cast curbstones. And you connect also this to the road, and it automatically connects to the inner surface of the tunnel. Free space. Very simple, just connect to the road and the free height. You can have several free space beside each other. The sign base, as default you have the lower face of the road bed as the base of the tunnel, but you can also decide to follow closed drainages or define the sign base by your own points like this. Clicking here, for instance. Bolts. mounting bolts you can define here, giving different location specifications, vertical, horizontal bolts, follow tunnel rotation, etc. The length of the bolts you can decide like this, and you can also insert new bolts, so you can define bolt groups like this. Niches. First you have to define the niche type. We have different types of niches that you can predefine with parameters. So here is one type, and then when you have defined the niche types, then you can insert the niches in the tunnel. So here is just one niche that is inserted, but if I wanted another one, in change number 110, the name of the niche is test, and then I can put it on the right side. I do like this. So in this way you can put out a lot of niches in the tunnel that are predefined in this niche type definition functionality. And crossing tunnels work exactly as for niches. You can define them here. I have several types. One is just square, the other one is with a bow ceiling, curved ceiling. So here you define all the corner points and the radiuses in the cross section, the offset of the perimeter, or you can define the perimeter as a standalone cross section. So here is one cross tunnel called test. And then again you go in here and define where the cross tunnels should be placed in the main tunnel. So here it's placed on change number 110 with this beta value 90 degrees, the height here 800 millimeters, etc. And in this way you can define several crossing tunnels at the same in the same group, and you can have several groups of crossing tunnels. Scanner data. You can define the colors of the points and the sections. You do in Novapoint 19, you do the triangulation outside Novapoint tunnel. But you can see the triangulation here, like data points and scanner profile. So then you can step through the tunnel and see how the scanner points are and the surface. It's a little bit long distance between the scanner points, so the surface is not really a continuous surface, but anyway. And you can also compare the areas between, for instance, the perimeter and the scanned surface, like this. And then you get all the distances, and you get the area value, and you get the average distance, the variance in the distance, and the standard value deviation of the distances. It says something about the roughness of the surface. So if you want all the distances, you can do like this. This is the design part of the tunnel module. If you now go back to Novapoint 19, we can also have a look at the registration of geology and rock support. That is something they do when they build the tunnel in Norway at the site where they construct the tunnel. So here we see the tunnel in unfolded perspective, plan view, unfolded. And what we see here is registration of cracks, foliation. It's also something we call Q value in Norway that says something about the quality of the rock. We also see the the bolts, these black circles, leakage. There are some information, a photo that can be looked at, taken inside the tunnel as they built it, etc. So if you take away the geology and the leakage information, we just have the rock support. So this is sprayed concrete, the blue one, and the bolts. So if I go there, I can go and have a look at the rock support in a table like this. This is in Norwegian, but it's all the rock support is registered in the tunnel like this and illustrated here. These are the blasts, so if I click here and go edit, I get information about the blast. Here is the two from chainage, and also some information can be written here about what happened each day. It's not so much information in this tunnel, but some tunnels, they write a lot here in the diary. It's a diary function. If I want to take out, for instance, a report of the rock support, I can go here and make an Excel report of the rock support. And then all the different rock support types are summarized in an Excel sheet, and this is a very good way of getting an overview of all the rock support you have put into the tunnel after the tunnel is finished and the rock support is covered by spray concrete. Comes out like this, with all the different types written here, and the summarized values, and then of course all the details further down in the spreadsheet. So this is the geology and rock support part of the tunnel application. And then we can go to the AutoCAD part. So inside here we have some functionality for Novapoint tunnel. I will just show you 3D drawing. It comes up a dialog like this, where you can order the different structure elements, decide the color, layer, name, etc. Here also I ordered scanner data, and then I press draw. That takes a while, and then it produces the 3D drawing of the total tunnel. This 3D drawing can then be imported back into the Novapoint 19 working area, so that you can see it together with the rest of the model. So now the tunnel will come out with both the main tube, the niche, a crossing tunnel, and the scanner data. This gives you a very good overview of the situation. And in addition to 3D, we have automatic cross-section drawing production, plan drawing production, and longitudinal cross-section production inside this AutoCAD part of Novapoint tunnel. So now the 3D model is finished. So here it is. So if you take it up, I don't know why you don't see it there. There it is. Like this. Yeah, here you can see the tunnel in 3D. Like this. See if I can get a nicer view. Yeah. So we can very clearly see what the red rock that is sticking outside the designed perimeter. The golden surface here is the design perimeter, and the red one is the rock. And then the blue points are the scanner points. Here we can see a niche, and we can see also the free space, driving space inside the tunnel. I see if I can get one more drawing up before we conclude the whole thing. I will now show you how we produced the overview drawings of the geology and rock support. It's like this, and then I order what the different components should be on the different sub-plan drawings that I produce. So if I go to layout here, see if the presentation follows. Yeah. Almost. There. So here we can see how we, with just a few clicks on the mouse, can produce very nice drawings showing all the geology registrations, all the rock support, all the Q values, etc. Also with an annotation included and a title field in the drawing. I think that concludes the very short presentation on the Novapoint channel and some of the functionality we did in the module. Thank you.
Thank you, Jan Erik. My name is Patrick McGloin. I'm a road design engineer. I'm going to show you now very quickly just some of the road design functionality in Novapoint Road. So here I have a Norwegian project. I'm just going to show you quickly how to build up a design project. So the first thing you normally do is import some kind of mapping data. The mapping data can be imported in 2D or 3D and is the first basis then for your design. Here I have a mapping data from an area in Norway. This mapping data in my case also includes 3D information, and then I can just view it in 3D. So the mapping format can be all kinds of format, LandXMLs, Genio, Norwegian mapping format and other international mapping formats, or it can be imported from an AutoCAD drawing. So here's the mapping data with the 3D information. From the mapping data, I can create then a terrain surface, and so I have a function in Novapoint 19 that selects what features I want to use, and from those can create the triangulation. And then if we just have a quick look at this, we see that we have generated from the same mapping data, we've created a 3D triangulation that represents the terrain surface. In addition, I can import supplementary information. In this case, we can have a quick look here. There's some this area here is representing a rock surface, and this can be as an area, or it can also be as points. Into this project, we've also imported some pipes and cables from the existing situation. And these are here. And these again can be imported either as 2D information or 3D information. Very often this information is only available in 2D, and then we can actually place them in relation to the terrain surface. Once I have in my mapping data and I have in other kinds of information that I want that are important for my design, I can continue to produce our design models. So in my case here, I've also imported this area where there's rock, and I've included a vegetation area. From the mapping data, I can very quickly produce volumes from mapping data. And so these are buildings, they're pipes, they're manholes, they're masts, and these then, using the modeling functions in Novapoint 19, I can create volumes. And the volumes are very useful then because they will appear in all my cross-sections and longitudinal profiles. So here, the input for this mast here is only a point. And then I've used this extrude vertical function to give it a diameter and a height. The pipes, I've just given them either a rectangular structure or a circular structure and generated them from just lines. And thus I create a very good model of the existing situation. These buildings have also been created automatically from the mapping data and given a volume. Once I've imported my mapping data and created my terrain surface, I can also drape an orthophoto on top of the terrain surface. And we'll have a look at that later on. Okay, when we have finished then with our mapping data, I can open this in AutoCAD and I can produce the alignments that I need. I can just quickly show maybe show one here maybe. So here's the mapping data drawn to AutoCAD from the model. In AutoCAD we also have a range of functions. For example, one of the most important functions is alignment design, and that's to produce a new alignment. We can very simply just pick IP points in our drawing and produce road alignments. The road alignments can be adjusted either numerically or they can be we can drag the alignment inside the drawing to place it where we want it. So we have full flexibility and we can also then of course add transitions wherever we want them. The transitions are shown in blue, the circles in red and the straights in green. I can go now and open an alignment that I've made previously. So that's an alignment that's inside my model, just to show it to you. So here's an existing alignment that I've created previously that follows the existing road in the map that I want to improve. If we go back to the model, we can have a quick look at this alignment. Because once I produce an alignment, it's available in the model at the same time. And here's the alignment. And of course the alignment then is available in 3D inside my model. And I can check it for accuracy and whether visually it's a good alignment. When I have an alignment, I can also then model a road, and here I have a road that I've modeled previously, and we can just see this in 3D. The road modeling is just simply to start the road modeling tool. It's to add the alignment, the 10,000 alignment that I made. It's to choose a design standard. And once you've chosen the design standard, then you can just build the road. We can just do a quick build here. So when you build a road, it removes the old road from the model and adds the new model. So when I build, what it does, it takes my design template and calculates against the terrain. We can also look at the cross sections in the road model viewer, and I can just show you, let's see, the objects now that I added from the mapping data. And here there is an electrical cable in the air, and here are there some pipes under the ground. And of course they're all shown then in my cross sections. And that was the point, to make volumes out of these elements rather than just points and lines, and then you will see them in the cross section. I can just find something here I'd like to show you. You see that I have full control over all the objects that are in the model. So I add them in as illustrations. The same thing I can do with my alignment design. I can add existing elements from the existing situation so that I can, for example, make my alignment match an existing bridge. The main advantage of Novapoint 19, of course, is that everything is stored as an object, and here I have the properties window, so I can click on any object in the model, for example, and I get it up traffic lane. I get it up in my object window. We can take a quick look at some of the other items that have been designed here. Here I have an intersection in this project, and there's an automatic intersection design function that will calculate an intersection. I can look at this intersection now in plan, and then the drawing rule, I can use it to see, for example, that I want to see this as with contours. So I can examine my water runoff in this area. Earlier, Jan Erik showed you a little bit the tunnel, and I can show you now, if we take the road that I just showed, we can take the alignment, and under structures here, we have, let me see, tunnel, sorry, under tunnel, we can take the tunnel that Jan Erik made. And then, of course, I get everything inside the one model, and I see that my road and my tunnel, whether they're matching or not. And Jan Erik has not done such a bad job here, because his tunnel is using the road as its calculation basis, and of course it should match. Let's just see if we can get this to work. I go to, for the orthophoto, I need to give it the link to the orthophoto files. And just take the incorrect path away, and we want to add it now onto the terrain. So if I take the terrain surface here and view and 3D. So we support both orthophoto and now you see I have the orthophoto on top of the terrain. So I can just finish this, and we can look at the orthophoto. So the orthophoto now is being put on top of the terrain. And if I add to this view, I take the orthophoto and I take all the existing objects we modeled. Let's see here, existing objects. So now I have my terrain surface, I have my orthophoto, and I have all the existing objects that I modeled. So I get all my buildings, I get all my poles, anything I've modeled from the mapping data, for example, my hedges, everything I get inside the model. So now I would just like to quickly also add the road. So I can go to my modeling tool, and I can make a new ground surface. I can use the existing one. Let's see here. And I want a ground surface with road, for example. And then I make a hole for the roads that I want to include, and we want to include the road 10,000. So we want to cut a hole into our terrain for the road that we had created. And that's finished. And now it recalculates the new triangulation. So I can show it to you in a second. So if we look at this now, you see I have cut into the terrain surface the road that I've designed. So now we can go back to our orthophoto. And I'd say I want to put the orthophoto not onto my terrain, but I want to put it onto my ground surface with the road. So now we can look at our orthophoto, our alignment, our road, and all the existing objects. Let's see, we take this, and this, and this, and then move that and that in our orthophoto. Right mouse click and show in 3D. And now I have my road cut into my terrain with everything that I've done to my road, and I have all my buildings, and I have all the other elements that's in the model. Manholes, pipes under the ground, and cable, or sorry, and mass, all inside the model. And this is a very useful tool then for the designer. We can, for example, take this here, and now we can run along the alignment, and I can zoom in and zoom out, and we can travel the alignment and check our design in relation to the existing terrain and in relation to the orthophoto. So here my design has been stopped at the roundabout and started after the roundabout. Okay, I think that's a short presentation. Novapoint 19 is a model-based solution where everything in the model is an object and it has attributes and information. It also has information with regard to whether it's an existing object or a design object, when it's been designed, who's been designed it, and all that. Thank you very much.